So in order to figure out what's the minimum velocity that you need to throw the projectile for it to reach the slanted line, you have to know about this concept. So let us say I have a river, right? And the river itself is flowing with a velocity of u. So if your objective is to just reach the other point, right? So what you have to do is, your objective is to just reach the other side, right? So just put all of your velocity component into achieving that goal. So let's say that you have the maximum speed in which you can swim is like 10 meter per second. So it would be wise for you to just swim with that 10 meter per second in the direction that completes your task. Instead of doing this, if I were to do something like 10 meter per second, maybe in this direction, maybe your vertical component is in completing the mission is just going to be like 6 meter per second. And now it'll just take more time. So the basic idea is that you should, if you want to achieve a certain task, then you should focus all of your energy into completing that task, right? So if we were to look at this question, they're asking you the minimum speed required for you to throw a projectile such that it goes and hits the slanted wall. So if we were to, hold on, I'll just draw the diagram a little better. And also they've given you the angle over here, which is 60 degrees. So all I want to do is to get my projectile from here till on the wall. And what's the shortest distance between here and the wall? It's of course gonna be the perpendicular distance. So if this is 60, this is gonna be 30, 90, and this angle over here is going to be 60. So what you have to do is just focus your velocity component of the projectile you're throwing into that direction. So that is the angle in which you're going to project the ball, 60 degrees. So let's say instead of having 60, I had where this is 30 degrees. So that time your answer would be, oh, you have to project the ball at an angle of 30 degrees. It's that simple. Because you want to focus all of your speed into the component that achieves your task. So in fact, I can show you like a Desmos graph that illustrates the same. So in this graph, uh, the line is inclined at an angle of 60 degrees, and you can see that whenever I vary the projectile angle, it peaks at an angle not at 30, not at 45, not at 52, not at 55, but really close to 60, right? So that's what we're looking for. It should just nick this. And in fact, if I were to draw the perpendicular to this line, which is somewhere over there, you can see that when I adjust the initial speed, which is this, to something, let's say 4. Right now, the ball hits it in two places, which means that the speed is excess and you don't want so much. So instead, you want it to touch it something like that in only one location, right? So that's what we're going to be doing. If I have something like this, it's not touching it at all, which means that I need to increase the speed. But if I do something like this, it means that the speed is too much. But you can make it touch by decreasing the angle. But this is not what we're looking for. We want the minimum speed. So this still needs to be at an angle of 60. And the velocity can be minimized in such a way. See, it just touches it. So now what we have to do is we can set up the trajectory equation. We know that the ball, when projected with some velocity u, is going to have a parabolic trajectory. And the line, like if we take this as, if we take this to be the coordinate axis, the projectile is going to take something like this, and the wall is going to be somewhere like that, where it intersects the y-axis and x-axis respectively. We want to find out this place. And note, there are no two intersection points because we need to find the minimum speed. And when you take the minimum speed, it's going to intersect only once. So what we can do is we can, let's say that this has some equation 1 and this has some equation 2. The point of intersection can be given by equating both of them and solving for the desired quantity. So that's what we'll be doing. So to find out the equation of trajectory of a projectile, we know that its x component is going to be u cos theta times t, and the y component is going to be u sin theta t minus half gt square. And now if you rearrange this, you can get t is equal to x divided by u cos theta. So now you can substitute this and you get y is equal to u tan theta minus half g x square by u square cos square theta. And now your equation of the line is going to be y divided by h plus x divided by root 3 h is equal to 1. And you can simplify this to get y is equal to minus x over root 3 plus h. And now you can equate these both and you get u, x tan theta, it's not u tan, x tan theta. You get x tan theta minus half gt square, half gx square over u square cos square theta is equal to minus x over root 3 plus h. So now you can substitute the value of tan theta because you know theta 60 degrees. So x root 3 minus half g x square divided by u square, and cos 60 is half, so into 4 equals minus x over root 3 plus h. And now you can bring this to that side and multiply the entire equation by 2 over here and 2 over here, because I want to get rid of this half. So you can get you can simplify this. I'll be writing it over here. You get 4g oh yeah, this should be u square, by the way. So I can multiply this and get something like 1 minus, oh no, this should be plus. So you get 4 by root 3 plus 2h is equal to 0. And now you finally make use of what they've given to you in the beginning. They've said that the minimum velocity required to reach the top is v naught. So we can say that v naught is equal to root of 2gh, right? And v naught square is equal to 2gh. So your h can be written as v naught square divided by 2g is equal to h. You know what, since we need 2h, v naught over g. So substituting this, we get 4g x square upon u square minus x into 4 divided by root 3 plus v naught square upon g is equal to 0. And now remember, this gives you the intersecting point where the parabola and the slanted line meet. Since you only want one solution, we can say that the discriminant is equal to 0. So b square minus 4ac is equal to 0. And here your b is going to be minus x, a is going to be this part over here, and c is going to be this. So solving this, you get x square, so 4 root 3, the whole square, is going to be 16 divided by 3 is equal to 4ac. 4 into a is 4g upon u square, v naught square upon g. So your g gets cancelled, 4 times, and you get 4 by 3 is equal to v naught square upon u square, and you can arrange your u. So u square is equal to 3 upon 4 v naught square, so u is equal to root 3 by 2 into v naught. So this is the answer that you get. And if you notice it real carefully, it's basically u is equal to v naught times sine 60. And where 60 degrees is the inclination of this line. So that's the minimum speed required in order to make the projectile touch the slanted wall.